Hi, it's Mrs. Moss here, and we're going to continue our discussion on energy and look at water and the different phases that water goes through with adding energy or taking energy away. So let's get started. First, we know that water comes in three phases: solid, liquid, and gas. So let's talk about that in terms of energy and its kinetic energy. Solid has a very little kinetic energy. Molecules will vibrate together within that solid. It has very strong bonds, and we know that solids do have a definite shape, like an ice cube, and it also has a volume to it. Well, liquid is a little different. When it's in its liquid state, it has more kinetic energy molecules that are moving freely, such as boiling water, right? It's not bonded rigidly, so it allows it to move. It does not have a definite shape, and it does have volume. And in its last phase as a gas, it's where we see the most molecules with kinetic energy molecules moving. They move very fast, and they're not bonded at all. And it does not have a definite shape, and it does not have a volume. Okay, so fill this in on your chart. So what are the changes of phase? Well, when we go from a solid to a liquid or from a liquid to a solid, we experience freezing, going from a liquid to a solid. And from a solid to a liquid, we call that melting. The process of going from a gas to a liquid is condensation. And the process of going from a liquid to a gas is vaporization, or sometimes called evaporation. We need to look at our earth science reference tables when we're discussing evaporation and the properties of water. So let's get out our reference table. Pause the video if you need to. We're going to just look at the front page and find the properties of water table. You'll notice that it talks about energy gained and energy released during these different processes. And you'll see these numbers along the side. These indicate how much energy it takes and uses during this process. So energy gained during melting is 334 joules per gram. Energy released during freezing is also 334 joules per gram. Now you notice these are the opposite processes, right? So one's going from a liquid to a solid and the other is going from a solid to a liquid. So those are opposite, they take less energy. Now when we look at vaporization, the energy gained during vaporization to go from a liquid to a gas, it takes a lot of energy, 2,260 joules per gram. And going from a gas to a liquid, it actually releases energy, and it does take a lot of energy that is released, 2,260 joules per gram. And at the bottom here, we just have that density at 3.9 degrees Celsius is 1 gram per milliliter. Now, when we talk about energy being released during these processes, we're talking about going from a liquid to a solid. So let's think about that for a moment, because if we're taking liquid water, in order to go make it become a solid, we need to freeze it. So that means we're going to lose energy. There's no heat energy being added to it. We need to take out that or release that energy from it. So it's going from a higher kinetic energy in the liquid, warmer temperatures, into a solid, a freezing temperature with a lower kinetic energy. So the energy is lost during this process. It also is lost when it goes from a gas to a liquid. Now this is called, as we've said before, condensation. Now this is something we need to think about. When you are going from a gas to a liquid and water is condensing, it actually is releasing energy. So if we're thinking in terms of releasing energy means cooling temperatures, this makes sense when we talk about our bodies and sweating. What happens is our bodies sweat, it goes from a liquid to a gas to a liquid, and as it condenses, it's actually releasing energy, so it makes us feel cooler. So it's kind of an interesting process, but these are both what we look at when we talk about energy being lost or temperatures actually cooling down. Now, looking at the opposite, when we talk about energy being absorbed or gained during these processes, we're talking about going from a lower kinetic energy or a cooler temperature to a higher kinetic energy or a warmer temperature. And in this case, we need to add energy to make that happen. So we add energy to a solid, and it melts and becomes the liquid, from ice to liquid water. Similarly, we go from a liquid into a gas. And in order to get that evaporation occurring and that steam from a boiling pot of water, we add energy, right? You have to turn the energy up and turn on the stove, and then you start to see water from the liquid in the pan or the pot condensing, or I'm sorry, evaporating out, and you see that steam. So that's actually, the steam becomes condensing, but we don't, and once it turns into that gas that like upper in the kitchen, we don't see it anymore. So we do not see vaporization. It's all around us, it's in the air that we breathe out, but we don't see the process of evaporation. When we talk about the heating curve of water and all these processes, adding energy and losing energy and becoming a solid to a liquid and a liquid to a gas, we have a chart that's called the heating curve of water. And this is a graph that shows as energy is added and what phases it goes to. So when we have ice as a solid and we add energy to it, it becomes a liquid, and then it becomes steam or a gas. During this phase here, the freezing phase, when we're going and releasing energy, it's going from water to ice. And when we go back from ice to water, we call that melting, right? We talked about this. And if you notice what's occurring on the chart, where these arrows are during these processes, notice that this is where the line is flat. Here we go, right here. The line is flat. There actually is no temperature change during these phase changes. The phase is changing, but the temperature actually remains steady during that process change. And this is known as latent heat. Okay, I want you to write that down in the corner somewhere, latent heat. And this just indicates that there's a phase change occurring. So no energy is being lost or added at that time during the phase change. So what happens to the temperature of the water during phase changes? Nothing. This is just what I was saying before. There is no change. This is known as latent heat. The energy absorbed by the water during phase changes we call latent heat. Okay, so that is the definition. I want you to write it down if it's not in your notes. Okay? And we're going to end here for now talking about the phase changes of water and liquid water and the energy that's involved with making that happen. We'll see you next time. Get all your notes down and have a great day.